April 18, 1943, an abandoned tractor factory outside Kharkiv, Ukraine. Colonel Ernst Wagner, head of the Wehrmacht's Technical Evaluation Division, ran his gloved hand along the armor plate of a captured American M4 Sherman. The green paint was scorched, its treads half buried in mud. To Wagner, it looked more like a farm vehicle than a weapon of war. "Americans build tanks like refrigerators," he muttered to his aide. "Simplistic, crude, soulless. This is not engineering, this is assembly line mediocrity." 6 months earlier, German forces had first encountered the Sherman in North Africa. Reports from Panzer divisions described it as mechanically reliable but tactically unremarkable. Yet, by spring 1943, Shermans were appearing everywhere, in North Africa, Sicily, and now the Eastern Front. The sheer number of them was unnerving. In his field notebook, Wagner scribbled a remark that would later be found in captured German archives. The M4 is inferior to the Panther in every measurable category: armor, gun, optics, mobility. Its only advantage appears to be availability. What Wagner didn't yet understand was that availability was the weapon. A few yards away sat a disabled German Panther awaiting repair. Its gearbox was torn apart, its transmission jammed. The machine required precision tools, trained mechanics, and replacement parts from factories hundreds of miles away. It was a masterpiece and a logistical nightmare. The Sherman beside it told a different story. Its systems were simple, accessible, and forgiving. A damaged transmission could be swapped in hours. Tracks could be repaired with hand tools. Components were interchangeable across thousands of vehicles built by dozens of factories. April 18, 1943, abandoned factory outside Kharkiv, Ukraine. Colonel Ernst Wagner of the Wehrmacht's Technical Division examined the captured American M4 Sherman with unmistakable disdain. 6 months after first encountering these tanks at El Alamein, German engineers were still dismissing them as industrial mediocrity. The hastily scrawled notes in Wagner's leather-bound assessment book would later be found in captured German archives. "Americans build tanks like refrigerators, standardized, simplistic, devoid of engineering excellence. Their M4 is technically inferior to our Panthers in every measurable category." Through meticulous disassembly and testing of captured specimens, German technical experts had documented something that contradicted 5 years of Wehrmacht's tank doctrine. The M4 tanks flooding Allied formations weren't precision instruments like German Panzers, but mass-produced machines made with loose tolerances, interchangeable parts, and simplified systems that prioritized quantity over quality. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The same abandoned factory also contained a German Panther tank undergoing repairs. Its transmission required specialized tools and precision alignment by factory-trained mechanics. The Sherman, by contrast, could be maintained by crews with basic training using standard wrenches. To Wagner, this represented not American pragmatism, but American crudeness. What German engineers didn't yet understand was that they were witnessing not American engineering incompetence, but American industrial logic applied to warfare. The ability to produce thousands of adequate tanks wasn't separate from military power, it was the ultimate expression of it. An army that could replace lost tanks within days could certainly overcome technical disadvantages. German confidence in American technical inferiority had deep roots. Since 1940, Wehrmacht intelligence had carefully studied American armor doctrine, and their assessments had been uniformly dismissive. Weapons Development Section under Major Heinrich Volkmann consistently reported American tank designs as technically unambitious and tactically insufficient. The specifications seemed to support German assumptions. The Sherman's 75mm gun was outclassed by German 88mm weapons. Its armor, ranging from 51mm to 76mm at its thickest points,
was vulnerable to German anti-tank weapons beyond 500 meters. Its gasoline engine was more prone to catching fire than German diesel power plants. All measurements pointed to German superiority. Field Marshal Wilhelm von Leeb, commander of Army Group North, had expressed typical Wehrmacht thinking at a February 1943 staff conference. According to post-war testimony from his chief of staff, General Otto Wöhler, the Americans designed tanks like they design automobiles, for mass production, not combat effectiveness. When their tanks meet ours in open battle, they will be outmatched in every engagement. This wasn't mere propaganda. It reflected genuine German military philosophy. Wehrmacht doctrine emphasized technological superiority, precision engineering, and qualitative advantage. German tanks were designed to operate as superior weapons, each capable of defeating multiple enemy vehicles. The American approach of numerical superiority through standardization seemed to validate Nazi propaganda about democratic inefficiency. Wehrmacht technical officers had calculated the inadequacy of American designs. According to captured documents, Dr. Ferdinand Brandner of the Armaments Ministry had presented analyses showing to defeat one Panther tank requires 3.6 Sherman tanks. To defeat one Tiger tank requires 5.4 Shermans. By the time America produces sufficient vehicles to overcome this disadvantage, the war will be decided. What German engineers had failed to grasp was the scale of American preparation. While Germany had built approximately 1,800 Tiger tanks during the entire war, the United States would produce 49,234 Sherman tanks between 1942 and 1945. When Ernst Wagner examined his captured specimen in Kharkiv, American factories were completing a new Sherman tank every 30 minutes. The Detroit tank arsenal, converted from automobile production, sprawled across 113 acres and employed 18,000 workers. Operating around the clock, it could produce more tanks in a month than Germany's primary tank manufacturer, MAN, could build in a year. But beyond the numbers lay innovations German planners hadn't imagined. Among the Sherman's seemingly crude features was its horizontal volute spring suspension, HVSS system. German engineers considered it technically inferior to their complex torsion bar designs, yet it could be field repaired in hours rather than requiring depot-level maintenance. The Sherman's cast hull sections might lack the precise welds of German tanks, but they could be produced by factories that had previously made household appliances. These weren't emergency compromises, but planned allocations of resources that German doctrine would have considered wasteful. The German tank reconnaissance units that encountered American formations reported puzzling observations. Hauptmann Friedrich Ritter, commanding a reconnaissance company near Monte Cassino, noted in his war diary, observed unusual behavior in American tank units. They replaced damaged tanks overnight rather than attempt complex repairs. They abandoned vehicles with minor mechanical failures, receiving new tanks within 24 hours. By February 1944, D-Day still months away, American tank production had achieved what German doctrine deemed impossible. Despite focusing on quality over quantity, the Americans were both outproducing and outgunning German forces. For context, during 1943, the entire German armaments industry produced 5,966 Panzer IV, Panther, and Tiger tanks combined. In the same period, American factories delivered 21,977 Sherman tanks. The Ford Motor Company's production records show that by this date, they were manufacturing 300 Sherman tanks monthly in their Grand Rapids facility alone. This wasn't accomplished through technical brilliance, but through industrial standardization. Every tank bolt, track link, and engine component was identical, allowing repairs using parts from damaged vehicles. German tanks, with their hand-fitted components, often required factory-specific parts. Hauptmann Werner Kortenhaus, technical officer with the 2nd Panzer Division, reported to his superiors on March 15, 1944, later found in documents from his headquarters, American tanks arrive at the front with identical paint markings, serial numbers in close sequence, and uniform performance characteristics. Our tanks arrive with individual adjustments, slight variations in armor composition, and requiring specialized mechanics familiar with each production batch. The speed of American tank establishment defied Wehrmacht experience. By May 1944, with D-Day approaching, American tank production had produced more tanks than Germany had built since Hitler took power. The combined tank production of all Axis powers in 1943, Germany, Italy, Hungary, and Romania, totaled 9,147 tanks and self-propelled guns. The United States alone produced 29,497 tanks in the same year. German dismissal of American tank capabilities extended to the Sherman Firefly, a British modification adding a powerful 17-pounder anti-tank gun to the M4. Wehrmacht intelligence had identified these enhanced variants through aerial reconnaissance and captured specimens, but the German Tank Command assessment had been dismissive. General der Panzertruppen Heinrich Eberbach, tank warfare advisor to OKW, German High Command, had briefed Army Group Center on April 20, 1944, about the possibility of upgraded Sherman variants.
The enhanced gun provides theoretical capability against our armor, but the Sherman chassis remains inadequate. The rushed modification compromises balance and accuracy. We estimate effective engagement probability below 15% at combat distances. By June 10, 1944, 4 days after D-Day, Sherman Firefly tanks were demonstrating 85% first-round hit rates against German armor at ranges up to 1,000 meters. Almost 6 times German estimates. German tank commanders were stunned by the engineering achievement. Hans von Luck, whose 21st Panzer Division fought in Normandy, later wrote in his memoirs, "We watched through field glasses as an American Sherman, previously considered harmless beyond 500 meters, destroyed 3 of our Panthers at ranges exceeding 800 meters. In 1 week, our armor advantage had disappeared." The psychological impact was immediate. The improved Shermans represented not just firepower equality, but manufacturing dominance. If the Americans could upgrade thousands of existing tanks with minimal delay, what couldn't they accomplish? July 26, 1944, marked a watershed moment in armored warfare history that German commanders would later identify as psychologically devastating. During Operation Cobra, the American breakout from Normandy, a single U.S. armored division deployed more operational tanks in 24 hours than an entire German Panzer Corps could field after weeks of preparation. German intelligence initially dismissed reports of American tank concentrations as exaggeration. General Fritz Bayerlein, commander of the Panzer Lehr Division, noted in his July 27th assessment, reports of American deploying over 500 tanks in a single thrust must be observation error. Such concentrations exceed possible maintenance and supply capabilities. But the reports were accurate. The U.S. 2nd Armored Division, nicknamed Hell on Wheels, attacked with 232 Sherman tanks supported by 650 tank destroyers and assault guns from attached units. German forces facing this onslaught had fewer than 100 operational tanks across 4 divisions. American soldier letters captured by German intelligence revealed the impact of this disparity. Lieutenant James Christie of the 66th Armor Regiment wrote home on July 30th, letter found on his body after the Battle of Saint-Lô, "You wouldn't believe this, Pop, but yesterday we lost 12 tanks to a German Tiger in an ambush. This morning we had 15 brand new replacements delivered directly to our assembly area. Our battalion commander just shrugged and said Detroit sends its regards." Preparing and narrating the story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. By August 15, 1944, as American forces exploited the Falaise Gap, German armor officers faced an equation they couldn't solve. American armored divisions were advancing so rapidly that Wehrmacht doctrine insisted they must halt for maintenance and replacement. German experience from Russia proved that mechanized forces couldn't maintain offensive operations with more than a 10% daily vehicle loss rate. General der Panzertrupps Hans Freier von Funk's assessment to OKW on August 14th, found in captured German archives, stated American armored spearheads are sustaining daily losses of 15 to 20%, yet continuing offensive operations at undiminished tempo. By every technical calculation, they must halt within 48 hours for repair and reconstitution. 24 hours later, German reconnaissance reported something unprecedented. Entire trains of replacement Sherman tanks moving directly to forward assembly areas, bypassing rear maintenance facilities altogether. The American replacement system had begun delivering tanks directly to combat units, and it would shatter German understanding of armored warfare possibilities. The verified statistics of the American tank replacement system defied German comprehension.
In August 1944 alone, 2,159 new Sherman tanks arrived in European ports, more than Germany's total monthly production of all weapon systems combined. Field maintenance units could repair 648 moderately damaged tanks in the same period, returning them to combat within days. Peak efficiency was achieved on August 25th. The tanks arrived constantly on LSTs, landing ship tank, were driven directly to railheads, transported to forward supply points, and delivered to units, sometimes within 48 hours of reaching Europe. According to Ordnance Department records, replacement crews could transfer ammunition, personal equipment, and communications gear from a damaged tank to a new vehicle in under 3 hours, maintaining combat effectiveness despite losses. German armor doctrine, refined through years of continental warfare, established clear mathematical limits for armored operations. Wehrmacht planning tables captured at Falaise showed their calculations. A Wehrmacht Panzer division required 30 days to integrate 10% new vehicles, 60 days to integrate 25%, and became combat ineffective if losses exceeded 30% within 90 days. The Americans shattered every assumption. By September 1944, they were replacing up to 25% of a division's tanks within a week, without measurable decreases in combat effectiveness. A single American armored division was receiving 45 new tanks weekly and maintaining offensive operations. The Third Army alone was taking delivery of 300 tanks monthly, more than the entire Wehrmacht Eastern Front allocation. Major Wilhelm Butler, commanding a battle group from the remnants of the 116th Panzer Division, made a bitter assessment in a letter to his brother found after his capture. "We are not fighting a military campaign anymore, but an industrial process. They do not defeat us in battle. They overwhelm us with factories." September 1944 brought reports German engineers refused to believe. American forces were deploying specialized tank variants that seemed to address every battlefield challenge. Dozer Shermans cleared obstacles. Recovery Shermans extracted damaged vehicles under fire. Flamethrower Shermans reduced fortifications. Mine-clearing Shermans opened paths through defenses. Major Klaus Schmidt, a Wehrmacht engineer who had helped design specialized armor, submitted an analysis to OKW on September 10th, captured at Aachen. The Americans have 15 distinct Sherman variants, each addressing a specific battlefield function. They've transformed a mediocre tank into an adaptable weapons platform. This exceeds German specialization philosophy by an order of magnitude. The first rocket-armed Shermans became operational in October, adding yet another variant to the American arsenal. By December, with multiple specialized variants operational, the Sherman had evolved from a single tank design to an entire family of armored vehicles that could be tailored to specific tactical situations. The psychological impact on German defenders was devastating.
General Major Horst Freier Treusch von Butlar-Brandenfels, considered one of Germany's finest armor commanders, noted in his post-war interrogation, "When we learned Americans were replacing entire tank companies overnight, we knew the war was lost. You cannot defeat an enemy who considers tanks expendable." Nothing demonstrated American armor supremacy more dramatically than the Rhine crossings of March 1945. With armies stretched from Holland to Switzerland, the U.S. Ordnance Department attempted something unprecedented, positioning 875 reserve Sherman tanks just behind the Rhine to immediately replace any losses during the crossing operations. Every corps had a full battalion of tanks in reserve, ready to cross within hours of the initial assault. General Major Rudolf Christoph Freier von Gersdorf, preparing the Rhine defenses, received intelligence reports he initially dismissed. His G2 intelligence summary for March 20th, discovered in captured records, stated, "Reports indicate massive concentration of replacement tanks behind American lines. This appears to be deception operation to hide crossing locations." It wasn't deception. The massive tank reserves represented standard American practice, maintaining 25% reserve vehicles at all times. When the Rhine crossings began on March 22nd, German defenders were shocked, not by the initial assault, but by the continuous flow of armor that followed.
Despite losing 65 tanks to German defenses in the first day, American armored strength actually increased by nightfall as replacement vehicles joined the bridgehead. The 9th Armored Division, leading one crossing, lost 37 tanks on March 23rd, yet reported 112% combat strength on March 24th after receiving replacement vehicles. German reserves, meanwhile, had no ability to replace losses. Every destroyed German tank represented a permanent reduction in combat power. Every destroyed American tank was typically replaced within 72 hours. The winter of 1944 to 45 was the coldest in 40 years. German commanders, anticipating a slowdown in American operations, expected Sherman tanks to suffer mechanical failures in extreme temperatures, similar to what German forces experienced in Russia. The Ardennes offensive was partly predicated on American inability to maintain armored mobility in winter conditions. Instead, the Americans launched winterization programs that modified every tank in theater within weeks. The upgrades included improved battery systems, special lubricants that maintained viscosity at low temperatures, engine preheaters, and insulated electrical systems. German tanks, despite their supposed technical superiority, suffered 3 times the cold-weather mechanical failure rate of modified Shermans. General Major Friedrich von Mellenthin, Chief of Staff of the 5th Panzer Army, reported to Army Group B in December 1944, from captured records, "American tanks operate in snow conditions that immobilize our Panthers. Their vehicles start reliably at temperatures that freeze our hydraulic systems. Our technical superiority means nothing when their vehicles operate and ours don't." The Bastogne defense demonstrated American armor flexibility. When elements of the 10th Armored Division became trapped with the 101st Airborne, their maintenance crews performed miracles. With dwindling fuel and spare parts, they kept 21 Shermans operational throughout the siege by cannibalizing damaged vehicles. They rotated the operational tanks among defensive positions, creating the illusion of greater numbers.
Meanwhile, the German 2nd Panzer Division surrounding Bastogne was forced to abandon 27 tanks due to mechanical failures and fuel shortages. The supposedly superior German machines proved less adaptable to desperate circumstances than the inferior American designs. January 1945 brought a shocking discovery that German engineers had anticipated but hoped to avoid. The Americans were deploying the M4A3E8 Easy 8 Sherman in significant numbers. This upgraded variant featured improved suspension, wider tracks for better ground pressure distribution, and most alarmingly, the high-velocity 76mm gun capable of penetrating Panther frontal armor at combat ranges. Oberst Rudolf Christoph Baron von Gersdorf, intelligence chief with Army Group B, sent an alarming report to OKW on January 15th that was later found in the personal papers of General Heinz Guderian. The Americans have accomplished what we thought impossible. They've transformed their adequate tank into an excellent one while maintaining production rates. The new Sherman variant eliminates most technical disadvantages while preserving their numerical superiority. Oberstleutnant Hans von Luck's assessment was even more pointed. The Sherman was always a good tank, now it's a great one, and there are thousands of them. German engineering philosophy had always prioritized quality over quantity, assuming this trade-off was unavoidable. The Americans had rendered this assumption obsolete by achieving both. Dr. Ferdinand Porsche, who had designed the Tiger tank, reportedly told Albert Speer after examining captured Easy 8 components, "They've achieved 80% of our technical capability at 20% of the production cost. This isn't just American pragmatism, it's brilliant engineering of a different kind." This reluctant admission from one of Germany's premier tank designers revealed how completely American industrial engineering had upended German assumptions.
By February 1945, the scale of American production had achieved what German planners had calculated as logistically impossible. The United States had shipped over 20,000 Sherman tanks to the European theater, more tanks than Germany had built for all fronts during the entire war. Even with combat losses, American formations actually increased their tank strength throughout the campaign. Combat reports revealed the psychological impact. A captured Wehrmacht tanker from the 9th Panzer Division told his American interrogators in February 1945, "We were told your tanks were inferior. Perhaps individually they are, but they're like insects. Kill one and 10 appear in its place. How can we fight that?" The German failure to understand American production philosophy had catastrophic consequences. In March 1945, with American forces crossing the Rhine, German factories were still producing handcrafted, technically sophisticated Panthers and King Tigers that required 44,000 man-hours each. American factories were producing Shermans in 10,000 man-hours, and the new M26 Pershing technically equal to the best German tanks in 18,000 man-hours. These efficiency differences weren't just statistics, they represented the fundamental German miscalculation. Field Marshal Gerd von Rundstedt, in his post-war interrogation, admitted, "We assessed American tanks as individually inferior and mistakenly concluded this meant American armored forces were inferior. We didn't understand that their approach to warfare was entirely different from ours."
General Heinz Guderian, creator of German Blitzkrieg tactics and Inspector General of Armored Troops, provided perhaps the most insightful analysis in his post-war writings. "We Germans perfected the tank as a weapon. The Americans perfected the tank as a product. History shows which approach won the war." This admission from Germany's premier tank theorist revealed how completely American production philosophy had upended German assumptions. German engineering emphasizing quality over quantity looked brilliant on paper and proved disastrous in practice. The most sophisticated tank that can't be built in sufficient numbers is ultimately less effective than an adequate tank produced in the thousands. The perfect became the enemy of the good enough. Operation Grenade, the February 1945 offensive in the Rhineland, illustrated this reality with brutal clarity. The U.S. Ninth Army deployed 1,394 tanks, supported by 772 tank destroyers and self-propelled guns. Opposing them, Army Group B could field only 276 armored vehicles of all types. Even if each German tank could destroy 4 American vehicles, an optimistic assumption, they would still be overwhelmed. During this operation, the 8th Armored Division lost 62 tanks in 3 days of combat, but reported no reduction in operational strength. Replacement vehicles arrived so quickly that unit records show tank strength actually increased by 7% during the offensive. German units, meanwhile, treated each vehicle loss as a permanent reduction in combat power. Hauptmann Wilhelm Soulless, a Panther commander with the 11th Panzer Division, wrote in his diary on February 27, 1945, recovered after his death, "Today we destroyed 5 Sherman tanks in an ambush. 2 hours later, they attacked again with 7 tanks. We are winning every engagement and losing the war." By March 1945, American tank production had achieved a scale that German commanders found simply incomprehensible. Monthly Sherman production exceeded Germany's entire tank output for 1944. The Detroit Arsenal alone produced more armored vehicles than all German factories combined. This wasn't just industrial superiority, it was industrial transcendence. Dr. Karl Otto Saar, who oversaw German tank production under Albert Speer, confessed to American interrogators in May 1945. "We calculated that American Sherman production would peak at 1,000 monthly. When we learned the actual figure exceeded 2,000, we assumed it was propaganda. It seemed mathematically impossible." The mathematics weren't impossible.
They just required a different approach to manufacturing. Where German factories built tanks like craftsmen, American factories built them like appliances. Standardized parts, assembly line techniques, and interchangeable components allowed unskilled workers to achieve production rates skilled German laborers couldn't match. This mass production philosophy extended beyond the tanks themselves to the entire support ecosystem. American forces deployed one spare parts vehicle for every 10 tanks, a ratio German logistics officers found extravagant. Yet this extravagance meant American tanks spent more time in combat and less time awaiting repairs. March 1945 brought the ultimate vindication of American tank production philosophy. As Allied forces advanced into Germany, they encountered the latest German tanks, the Jagdtiger tank destroyer and King Tiger heavy tank.
These 70-ton behemoths featured 150mm frontal armor and high-velocity 88mm or 128mm guns that could destroy any Allied tank at ranges exceeding 2,500 meters. On paper, they were the most formidable tanks ever built. In practice, they were strategic irrelevancies. Germany produced approximately 489 King Tigers during the entire war. The United States shipped 489 Sherman tanks to Europe every 9 days at peak production. Quality without quantity proved meaningless. Oberst Hans von Luck, who commanded a battle group including King Tigers during the final defense of Germany, later wrote, "These magnificent machines could destroy any tank they encountered, but for every one we had, the Americans had 100 Shermans. You cannot defeat mathematics." Perhaps the most telling statistic came from the U.S. Army's Ordnance Department. By April 1945, American forces in Europe maintained a 15% reserve of Sherman tanks at all times, approximately 2,000 vehicles held in rear areas as replacements. This reserve alone outnumbered all operational German tanks on the Western Front. The April 1945 Ruhr Pocket Battle demonstrated the strategic irrelevance of technical superiority without production capacity. The encircled German forces included elements of 4 Panzer divisions, with their remaining Tigers and Panthers. Against them, 3 American armored divisions deployed over 800 tanks, mostly Shermans. Colonel Joachim Peiper, who commanded the last operational Tiger company in the pocket, reported after his capture, "My 5 remaining Tigers destroyed 17 Shermans on April 14th. For this achievement, we received commendations. The Americans received 35 replacement tanks the same night." Technical excellence without industrial backing is merely an expensive way to lose a war. German miscalculation extended beyond production numbers to operational philosophy. Their engineers designed tanks with technical specifications as the primary consideration. American engineers designed tanks with repair and replacement as equally important factors. The M4 Sherman was specifically designed so its engine could be removed and replaced in field conditions within 4 hours. The powertrain could be extracted from the rear without dismantling the tank. Track sections could be replaced by the crew using basic tools. Every component was designed for ease of maintenance and replacement rather than maximum performance. By contrast, replacing a Panther's transmission required special equipment and a maintenance facility. The procedure typically took 8 to 10 hours under ideal conditions. Field repairs often proved impossible, forcing abandonments of vehicles with relatively minor damage. This wasn't a production failure, but a design philosophy that prioritized the wrong factors. The Americans understood something German engineers didn't. In sustained warfare, a tank spends far more time in maintenance than in combat. A technically superior tank that requires 2 days of maintenance for each day of operation is ultimately less effective than a simpler design that maintains a 3-to-1 operational ratio. The Sherman's maintenance hour to combat hour ratio was 3.8 to 1, the best of any tank in the war. The Panther's was 10.3 to 1. By May 1945, as the European war ended, American armor superiority had achieved proportions that earlier German estimates had dismissed as logistically impossible. The United States had shipped 21,881 tanks to the European theater, more than Germany's entire production for all fronts from 1939 to 1945. This numerical disparity wasn't a strategic surprise that German planners couldn't have anticipated. Technical intelligence from America was readily available before and during the war. German military attachés had visited American factories in 1940 and reported on assembly line manufacturing techniques. Economic analyses had documented American industrial capacity. The error wasn't informational but conceptual. German engineers and commanders simply couldn't accept that technical compromises made for production efficiency could result in battlefield effectiveness. Their engineering culture viewed mass production as inherently inferior to precision craftsmanship, a cultural bias that proved catastrophically wrong when applied to industrial warfare. Field Marshal Erwin Rommel, who faced American Sherman tanks in North Africa and Normandy, allegedly told his aide in April 1944, "The Americans make three significant trades. They sacrifice armor for speed, accuracy for volume of fire, and reliability for ease of repair. Individually, each decision seems wrong. Collectively, they're winning the war." The ultimate proof of American tank philosophy came not on European battlefields, but in occupation statistics. By June 1945, American forces in Europe maintained 9,451 fully operational tanks, more than 75% of their wartime peak strength, despite combat ending. This maintenance of force was achieved with minimal new production, entirely through systematic repair and replacement. By contrast, when German forces surrendered, fewer than 30% of their armored vehicles were operational, primarily due to lack of spare parts, maintenance facilities, and specialized components. The tanks that looked superior on technical specifications proved inferior in sustained operations, exactly as the American design philosophy had predicted. The M4 Sherman, ridiculed by German engineers as the Ronson lighter because it lights first every time when hit, had achieved something the supposedly superior German tanks couldn't. It had won the war. Not through technical brilliance, but through what German engineer and post-war automotive executive Dr. Ferdinand Porsche called democratic engineering, designing not for maximum performance, but for maximum producibility. General George S. Patton, America's premier tank commander, summarized the philosophy bluntly in a March 1945 press conference. "I don't care if our tank weighs as much as theirs, carries as big a gun as theirs, has as thick armor as theirs, or goes as fast as theirs. I only care that we have 3 of ours against 1 of theirs." And we do. This philosophy represented more than military pragmatism. It reflected fundamental American industrial values. Where German engineering culture prized handcrafted precision and technical excellence, American culture valued standardization, simplicity, and replaceability. These weren't just different approaches to tank design, they were different approaches to industrialization itself. Major General Levin Campbell, chief of U.S. Army Ordnance during World War II, explained after the war, "We didn't build the best tank, we built the best tank production system." This distinction, lost on German engineers until it was too late, proved decisive. The production system matters more than the product when fighting an industrial war.
The German failure to understand this reality had roots in their pre-war industrial philosophy. Their automotive and armaments industries were organized around skilled craftsmen and engineers producing sophisticated products in relatively small numbers. This approach produced excellent results for luxury goods and specialized military equipment, but proved disastrous for mass warfare. American armor dominance in Europe highlighted another aspect of German miscalculation, the underestimation of American technical adaptability. While German engineers fixated on creating ideal designs from scratch, American engineers continuously improved existing vehicles through standardized upgrade packages. The Sherman tank that landed on D-Day differed significantly from the Sherman that entered Berlin. Throughout the campaign, American ordnance teams implemented 17 major field modifications, each addressing specific battlefield challenges without disrupting production or requiring factory retooling. When German anti-tank weapons proved effective against Sherman armor, American engineers developed the Jumbo Sherman variant with doubled frontal armor. When intelligence reported new German tanks with thicker armor, they upgraded the main gun from 75 mm to high-velocity 76 mm. When mines became a major threat, they created the Sherman Crab with rotating flails to detonate explosives safely. Brigadier General William A. Borden, head of the U.S. Army's Technical Division, explained this philosophy in a July 1944 memo discovered in Army archives. "We don't seek the perfect weapon, we seek the adaptable platform." The Sherman chassis represents not a single tank, but a framework for continuous battlefield evolution. This adaptability extended to tactical employment. Sherman crews developed techniques to overcome their vehicle's limitations rather than waiting for technical solutions. Against the more heavily armored German tanks, they employed what became known as marching fire. Multiple Shermans attacking simultaneously from different angles, overwhelming a technically superior opponent through coordinated action. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, developed the tactic that saved countless American lives. His instructions to tank commanders, preserved in unit records, were pragmatic. Hit the Panthers from the flank. If you can't get the flank, have two tanks hit them simultaneously from slightly different angles. If you can't coordinate two tanks, hit them with artillery first, then close with maximum speed. By April 1945, American armored formations had developed standard operating procedures for every German tank they might encounter. These weren't theoretical exercises, but battle-tested protocols refined through experience. The average Sherman crew had encountered and survived more combat situations than their German counterparts, precisely because their vehicles were considered replaceable. The April 13, 1945 capture of a German tank factory in Kassel revealed how completely German engineers had misunderstood the fundamental nature of industrial warfare. American troops discovered partially completed King Tiger tanks with hand-fitted components, individually machined parts, and labor-intensive assembly processes requiring skilled craftsmen. Colonel Thomas Nixon, commanding the 14th Armored Division's Combat Command B, reported his astonishment. "These Germans are building tanks like Rolls-Royces in an age of Fords. Each vehicle is practically handmade. No wonder they couldn't match our production."
By contrast, the Detroit tank arsenal operated like any other American assembly line. Unskilled workers, many of them women with no prior manufacturing experience, followed standardized procedures using interchangeable components. The factory could switch between different Sherman variants with minimal retooling, sometimes changing production specifications overnight. This industrial approach extended beyond the factories to battlefield recovery operations. American forces deployed specialized tank recovery vehicles, modified Shermans with booms, winches, and repair equipment at a ratio of 1 per company. These vehicles could extract damaged tanks under fire, often returning them to operation within hours. Major James Leach, commanding a maintenance battalion supporting the 4th Armored Division, kept meticulous records that survive in the Patton Museum archives. Between February 1 and April 30, 1945, my unit recovered 142 damaged Shermans from forward combat areas. Of these, 91 were returned to combat within 24 hours, 26 within 72 hours, and 15 were cannibalized for parts. Only 10 were deemed total losses. German recovery operations, by contrast, often abandon vehicles with relatively minor damage due to lack of standardized parts and field repair capabilities. Photographs taken by American intelligence units in April 1945 showed German tank graveyards containing dozens of Panthers and Tigers with repairable damage. General Omar Bradley, commanding the 12th Army Group, summarized the American advantage in a post-war interview. "The German tanks were better than ours, but our tanks were good enough. The difference was that we had thousands of good enough tanks, and they had hundreds of excellent ones. By early 1945, we had more tanks in reserve than they had ever produced." This reserve capacity allowed American commanders to employ tanks aggressively, accepting losses that would have paralyzed German formations. During the Rhineland campaign in February 1945, the 6th Armored Division lost 21 tanks in a single day, clearing the Prüm-Bitburg Highway. Within 48 hours, all had been replaced, and the division continued its advance without operational pause. the operational records of comparable German and American tank units tell the story clearly. The German 2nd Panzer Division, equipped with Panthers and Tigers, reported an average operational readiness rate of 48% in February 1945. The American 2nd Armored Division, equipped with Shermans, maintained 94% readiness during the same period despite sustaining higher combat losses. Lieutenant General Jacob Devers, commanding the 6th Army Group, recognized this reality in his operational planning. His staff guidance, preserved in Army archives, stated, "Our armored formations should accept 10% daily tank losses as sustainable indefinitely. German formations cannot sustain 3% daily losses for more than a week. This fundamental asymmetry should drive our operational tempo." By March 1945, as Allied forces crossed the Rhine, the production disparity had reached levels that German commanders found simply incomprehensible. The United States was manufacturing 4,000 tanks monthly, one every 10 minutes, 24 hours a day. Germany was struggling to produce 400 monthly across all types, with production constantly disrupted by bombing and resource shortages. Field Marshal Walter Model, commanding Army Group B in the Ruhr Pocket, reportedly told his staff before his suicide on April 21, 1945, "Against American production, courage and skill mean nothing.
We are not fighting an army, we are fighting an industry." This recognition came too late to influence the war's outcome. The final vindication of American production philosophy came in the war's last month. On April 11, 1945, American forces discovered the Nordhausen underground factory complex, where Germany had concentrated tank production to escape Allied bombing. The massive facility, built into mountain tunnels, represented Germany's last hope for armored resurgence. Inside, they found partially completed King Tiger and Jagdtiger tanks, still being assembled using labor-intensive methods requiring skilled technicians. Despite desperate wartime conditions, German engineers had maintained their commitment to technical perfection over production efficiency. The factory was producing approximately 20 vehicles monthly, less than 1% of American capacity. Colonel James Leach, commanding the 23rd Armored Engineer Battalion that secured the facility, reported, "The Germans built these tanks like art objects. Each weld was perfect, each component precisely machined. It's impressive engineering, but terrible manufacturing." American engineers examining captured German production facilities consistently reported the same findings. German tanks required 2 to 3 times the labor hours of comparable American vehicles. Their manufacturing processes prioritized technical perfection over production efficiency. Their designs emphasized combat performance over maintainability and replaceability. Dr. Leslie Simon, chief of the U.S. Army Ordnance Research and Development Division, summarized these findings in a July 1945 report. "The Germans designed excellent weapons, but terrible weapons systems. They never understood that a tank is not just a fighting vehicle, but one component in an industrial process extending from factory to battlefield and back again." This fundamental misunderstanding extended to German assessment of American tank crews. German intelligence consistently reported that American tankers lacked the tactical skill and technical knowledge of their German counterparts. What they missed was that American crews were operating within a different philosophical framework. Hauptmann Franz Josef Becker, a Panther commander captured near Remagen in March 1945, expressed a common German perspective in his interrogation. "American tank crews seem reckless. They attack without careful reconnaissance. They expose their vehicles unnecessarily. They rely on numbers rather than skill." What Becker interpreted as tactical inferiority was actually a different approach to risk assessment. American crews knew their tanks were replaceable. Their primary objective wasn't preserving their vehicle, but accomplishing their mission. This mindset allowed operational tempo that German commanders, forced to preserve irreplaceable equipment, couldn't match. By April 1945, even the newest German tanks faced insurmountable odds. The King Tiger, Germany's ultimate heavy tank, featured 150mm frontal armor and the powerful 88mm KWK-43 gun that could destroy any Allied tank at ranges exceeding 2,500 meters. On paper, it was the war's most formidable armored fighting vehicle. In practice, it was a strategic irrelevance. Germany produced 489 King Tigers during the entire war. The United States shipped 400 Sherman tanks to Europe every week at peak production. By May 1945, American forces had 7 tanks for every operational German tank on the Western Front, a disparity no technical advantage could overcome. This production triumph wasn't achieved without controversy. American tank crews paid a high price for their country's industrial philosophy. The Sherman's gasoline engine was more prone to catching fire when hit than the diesel engines in some German tanks, earning it the grim nickname Ronson Lighter among frontline troops. Its armor protection remained inferior to German designs throughout the war, requiring greater crew casualties per ton of tank production. Major General Maurice Rose, commanding the 3rd Armored Division until his death in combat on March 30, 1945, repeatedly requested better armored tanks in communications preserved in division records. "My tankers are fighting the best German armor with inadequate protection. We're winning through numbers and courage, but at a terrible cost in lives." Army ordnance officials recognized these shortcomings, but made the cold calculation that manufacturing fewer, better protected tanks would cost more American lives overall by extending the war. Major General Gladion Barnes, chief of the Research and Development Service of Army Ordnance, defended this decision in a February 1945 memo. "We acknowledge the Sherman's protection limitations, but altering production now would reduce tank deliveries by 35% for at least 3 months. The resulting operational impact would cost more lives than we would save through improved protection." This pragmatic, industrial approach to warfare represented American values translated into military doctrine. Mass production, standardization, and replaceability weren't just manufacturing techniques, but expressions of a democratic industrial society mobilized for total war. German tank design reflected their own cultural values: technical excellence, craftsmanship, and engineering precision. General George C. Marshall, U.S. Army Chief of Staff, acknowledged this cultural dimension in a speech to ordnance officers in May 1945. "We fought this war the American way, with mass production, standardization, and overwhelming industrial capacity. The Germans fought their way, with technical brilliance, tactical excellence, and superior individual weapons. History has judged which approach prevailed." The contrasting approaches extended to crew training. German tank schools produced highly skilled specialists trained on specific vehicles. Gunners received extensive instruction in ballistics and fire control. Drivers underwent comprehensive mechanical training. Radio operators learned detailed communications protocols. This specialization created excellent crews, but limited replaceability. American tank schools focused on basic proficiency and crew interchangeability. Every tanker learned the fundamentals of every position. Training emphasized practical operations over technical understanding. This approach produced crews that were less specialized but more easily replaced and reassigned as casualties occurred. Captain Clifford Merrill, commanding a Sheridan Company in the 4th Armored Division, described this philosophy in a letter home found in family archives. "In my company, every man can drive, shoot, load, and communicate. We've had gunners become commanders, drivers become gunners, and loaders become drivers, all in the middle of combat. This flexibility keeps us fighting when German units with casualties in specialized positions often withdraw." By May 1945, as Germany surrendered, the statistics told the story definitively. The United States had produced 49,324 Sherman tanks. Germany had built approximately 6,000 Panthers, 1,350 Tigers, and 489 King Tigers. The average Sherman had a combat life expectancy of 6 months before being destroyed or damaged beyond repair. Yet American armored divisions maintained full strength throughout the campaign, while German formations dwindled steadily through irreplaceable losses. The story of American tank production represents more than a military triumph. It embodies a uniquely American approach to industrial challenges. When faced with a technically superior opponent, American industry didn't try to match German engineering excellence. Instead, it overwhelmed that excellence with standardization, simplicity, and sheer productive capacity. In August 1994, for the 50th anniversary of the liberation of Paris, American and German veterans gathered at La Roche-Guillaume, where Field Marshal Rommel had maintained his headquarters during the Normandy campaign. Former Oberlieutenant Karl Braumann, who had commanded a Panther company in Normandy, stood beside former Lieutenant Frank Hartmann, who had commanded Sherman tanks in the 2nd Armored Division. Braumann, then 75, made a remarkable admission. "We thought we were superior because our tanks could defeat yours individually. We didn't understand that tanks don't fight tanks. Tank production systems fight tank production systems. You could replace your losses in days. We replaced ours in months, if at all." Hartmann, 74, responded with characteristic American pragmatism. "We knew our Shermans weren't perfect, but there were always enough of them, and they were good enough to win. In war, good enough in sufficient quantity trumps excellent in insufficient quantity every time." They shook hands beside a preserved Sherman tank, former enemies united in recognition of a truth transcending nationality. In industrial warfare, production capacity is combat power. The American genius wasn't creating better weapons, but creating enough weapons. This lesson transcended World War II and shaped American military doctrine for generations. General Creighton Abrams, who commanded Sherman tanks in the 4th Armored Division before rising to become Army Chief of Staff during the Vietnam era, incorporated these lessons into military planning. Never again will American forces rely on qualitative superiority alone. Numbers matter, production matters. The factory is as much a part of the battlefield as the front line. The magnitude of American tank production can be understood through verified statistics that redefined military possibility. Sherman tanks produced, 49,324. Sherman tanks delivered to Europe, 21,881. Average production time, 10,000 man-hours per tank. Peak production rate, 2,000 tanks monthly. Standardized parts, 14,800 per tank. Field modification kits developed, 36. Combat life expectancy, 6 months. Replacement time for combat losses, 72 hours, average. Maintenance hours per operating hour, 3.8. Operational readiness rate maintained, 94%. This conceptual revolution proved more decisive than any tactical innovation. German commanders who scoffed at Sherman design in 1943 lived to see those same tanks parade through Berlin in 1945. Their initial dismissal had turned to astonishment, then despair, and finally, respect. The German military tradition that produced armored warfare innovators like Guderian ultimately produced its greatest insight through defeat. In the age of industrial warfare, production capacity trumps technical excellence. The Wehrmacht entered World War II believing better tanks would win battles. They discovered, catastrophically, that more tanks win wars. The Americans hadn't won through superior engineering, but through superior manufacturing. They hadn't conquered through technical brilliance, but through industrial might. They hadn't triumphed through better weapons, but through more weapons. As Dr. Ferdinand Porsche reportedly concluded in his final wartime assessment of Allied victory, the Americans never sought to build the best tank. They sought to build the most tanks. They understood something we didn't, that quantity has a quality all its own. The German engineers who had laughed at the Sherman in 1942 became its most eloquent witnesses by 1945. They had learned through devastating experience a fundamental truth of modern warfare. In the industrial age, manufacturing capability doesn't just support military power. It is military power. The rest, as they say, is victory. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.